Hello guys, so welcome back to my YouTube channel, and for today's vlog we will be talking about this important piece of electronic equipment, the timer. So in this video we will wire this piece of electronic equipment in actual, so that you will know on how to properly wire the timers. So when do we use the timers? Is it just to count and when it will be activated? That's what we are going to talk right now. Timers can be used in different kinds of applications, but in this video we will just be focusing on the most common application in the vessel. You will see this most of the times in the boilers, in the cranes, in the machineries where it requires start and stop operation. The most common timers that we use on board are the on delay, off delay, and those which we use for switching. So why do we use the timers? If you hear the word timer, of course it will start counting, right? So in the vessel we normally use the timer to protect the machineries and equipment we are operating, and we use the timers to keep the system running and avoid false alarms. And we use the timer to activate piece of equipment in a sequence manner, and most of the time really they are being used to protect the equipment. Let's say for example the crane. So we have this so-called instantaneous current. So if the operator of the crane is not that good in the precision, and then he will keep on pressing the, let's say, up down button just to get the hook on the load, he will keep on pressing up without any rest. Of course, the inrush current for the electric motor, which eventually in later time will damage the motor. So they put the timer, like set it for 1 second or 2 seconds. After he pressed up, the timer will be activated before the crane will start running again. For the main air compressors, then we use the timers for the shifting from Y to delta operation, or even for the direct online operations. So let's say for the auxiliary boiler. For the auxiliary boiler you have the drum. So the vessel tends to sail in a rough seas. So once the vessel will roll, and then the level of water will sometimes affect will also be dancing inside. So once it's shifted to the port side and then to the starboard side, and then the level of water will also be affected, and then you might have a high level alarm on the drum which will trip the system. So most of the time they put timer in there and set it for 10 seconds, like if the ships roll, and then you'll have a false low water level alarm, and then the timer will be activated and start counting for 10 seconds, and then once the vessel will align, and then the alarm will reset without tripping boiler operation. It's same as for the high water level. In this way, the timer is very important or very essential in this kind of machineries. For the filters, so you have set the timer on how many flush it will be doing for the next 24 hours or 24/7. You have set it like 48 times it will flush to clean the filters, so that it will do it automatically. So if you go unmanned, if you go on the cabin, on your own cabin, and then you will knock off there, the timer will do the job in activating your electric motor to do the flushing and cleaning of your filters. So what I am saying right now and sharing to you are the general purpose and applications of timer on board. I am going to show you on how to wire an on delay timer, and then from there you will have an idea, especially for the beginners, on the application of the timers, how to wire it and how to understand the built-in electrical wiring diagram inside. So let's go to the workshop and I'll show you on how to wire this on delay timer. So this is an on delay timer. So what you can see right now is it has an option of two inputs for 24 volts and 240 volts. For 24 volts, we can put the input wires on 9 and 10 terminals, and for the 220 volts, we can put it on 2 and 7 terminals. So it depends on the application, so we can use 9 and 10 or 2 and 7. To understand these symbols further, then we will use the multimeter for better explanation. So I'm using this Fluke multimeter, and we will use, of course, the resistance in checking the continuity of the normally open and normally closed. And on the timer internal wiring diagram, it says that terminals 5 and 8 are the normally closed contacts, which means that when the timer is off, then 5 and 8 are normally closed, and 8 and 6 are normally open. And once the timer is activated, then it will start counting on whatever settings you put on the timer, and the closed contact will then shifted to terminals 8 and 6. And on the other hand, the terminals 1 and 4 are in closed contacts, which means that these terminals will always be at close contact, and once the timer is activated without counting, the close contact will shift to terminals 1 and 3. And so to understand it further, we will do an actual wirings on this timer so that you will see the activations of each terminals using a light bulb. So we will use the 220 input and we will connect the wires on 2 and 7. And since this is an on delay timer, we will connect the wirings of the light bulb on terminals 8 and 6. Once the timer is switched on, it will start counting on whatever the time settings we put onto the timer, and it will light up once that counting is finished. Before we activate it, let's explain first the multiple and range settings. So in every timers, you will always have the settings for whatever it is on seconds or in minutes or in hours. So that's why I chose this one, so that it is not just the normal or the usual simple autotronics timer where you can turn the knob and change the settings. So as you can see, these three dip switches, the first two are for range and the third one is for multiple. So what does it mean? At this position, then you have a 0.1 second range. At this position, you will have 1 second, and then just follow the range position of this dip switches, whether you will use 0.1 second, 1 second, 1 minute, or 1 hour. And then this is the multiple, whether in this position it is by 2, multiple by 2, or by 1. So it means at this position, the first two is set at seconds, then you have a multiple of 2, and then you are set at 5. So it means at the second multiply by 2, then this one is set to 10 seconds. But if we move the multiple on this position, and then you will have 5 seconds multiplied by 1, which is 5 at 5 seconds. But if the first two dip switches are on this settings at 1 second, it means 1 minute because of that position, and then by multiply by 1. So this 5 multiplied by 1, which is 5 at settings of minutes. So the on delay will be activated after 5 minutes. Of course, during testing we will just use the settings of seconds. Now let's activate the light bulb. 5, 4, 3, 2, 1, and go. Imagine if this is your electrical motor
As soon as you press the start button, then the motor will just start after 5 seconds. So you have a 5 seconds delay before you activated the motor. So depending on the application, you can set it for 2 seconds, 3 seconds, or even in minutes, depending on the machineries of application. Then the load will be activated on that kind of setting. So from the word itself on delay, the timer will be activated and then it will start counting before it will activate the load. So now we transfer the wirings on the terminals number 1 and 3 and we will activate again the timer. So this operation will only switch the terminals from 1 and 4 to 3 as soon as the timer will be activated without even counting. So it means it is only being used for switching. So that is the other application of these timers for the terminals number 1, 4, and 3. The load will stay on as long as the timer is on and will be off as soon as the timer will be deactivated.
So that's it, guys. Spread the love and I salute everyone. See you on my next video.